Uranus and Neptune have been confusing scientists since the moment we sent probes past them. Their magnetic fields are wrong, tilted, offset, chaotic in ways that don't match anything in our solar system. One of them radiates almost no heat, despite being a hot world. The other radiates nearly twice as much heat as it receives from the sun. The pressure inside them is so extreme, it makes matter behave strangely. For decades, scientists built models of what's inside these planets. The models kept failing. Now, a team at Carnegie Science has found something. They found a state of matter that does not exist anywhere on Earth, a state that's both solid and liquid at the same time, and it's threaded through the interior of the two most mysterious planets in our solar system. Welcome to Exophiles. Most solar system content focuses on Mars, Jupiter, or Saturn's rings. Uranus and Neptune don't get the same attention. They're far out, hard to reach. Our only close-up visit was a single Voyager 2 flyby decades ago, a few hours of data from a spacecraft moving at 60,000 kilometers per hour. And yet these two planets are the most scientifically strange objects in the solar system. They break rules. They defy models. New research from Carnegie Science, published in Nature Communications in March 2026, may have just cracked the biggest secret. Today I'll show you why these planets are so weird, what the new state of matter is, and what it means for the search for life. Let's start with what we know. Uranus and Neptune are called ice giants. That name is already misleading. They have dense interiors composed primarily of water, methane, and ammonia, but under pressures so extreme, they don't behave like ice. Problem 1. The magnetic fields. Earth has a magnetic field that is neat and predictable, like a bar magnet. Uranus and Neptune have magnetic fields that look like someone threw darts at a globe blindfolded. Uranus's field is tilted 59 degrees. Neptune's is tilted 47 degrees and offset. Problem 2. Heat output. Neptune radiates 2.6 times more energy than it receives. Uranus radiates almost no excess heat at all. Two nearly identical planets, completely different heat behavior. Problem 3. The interior layers. The density measurements don't match any simple model. Carnegie's Kong Liu and Ronald Cohen may have found why. In a superionic material, you have two different types of atoms behaving in completely different ways at the same time. One type of atom forms a rigid, solid, crystalline framework. The other type flows through that framework like a liquid. It is simultaneously solid and liquid. In the carbon hydride deep inside these planets, the hydrogen atoms don't just flow freely. They move along specific spiral pathways. Electricity and heat don't flow equally in all directions. They flow preferentially along those hydrogen channels. This happens at extreme pressures. The magnetic field problem. Earth's field comes from liquid iron. Uranus and Neptune's activity comes from conductive water and ammonia. If conductivity flows along hydrogen channels rather than uniformly, the electrical currents generating the magnetic field are inherently directional and asymmetric. The heat output problem. Directional hydrogen movement means heat doesn't flow evenly. Heat transfer may be channeled or blocked. This explains why Neptune radiates so much more heat than Uranus. Subtle differences in the internal geometry create dramatically different behavior. Uranus has 28 known moons. Neptune has 16. Several, like Titania, Oberon, and Triton, are considered candidate ocean worlds. If the internal dynamics could produce more complex heat patterns, there may be more possible pockets of warmth on these moons. 1. Uranus and Neptune have chaotic magnetic fields. 2. A new superionic state of carbon hydride has been predicted where hydrogen flows in spirals. Exophiles exists because this is the level of detail space science deserves. Not just Uranus is weird, but why it's weird. Subscribe for more.